switched on. We good? So, my name's Mark Rendell, also known as Marcos, and I work for Accenture, and I run a team that support about 15 big enterprise clients, helping them do continuous delivery on our projects where we work. So, this gives us a wide exposure to tools, techniques, processes, platforms, and also, our fair share of the challenges that come along with trying to do continuous delivery. And I like to call that continuous delivery impedance. And I'm here today to talk about that and how we overcome it. So we've heard a lot today about what continuous delivery is, but I'm going to just give my quick perspective on that and underline a couple of things that I think, three things that I think are really important to get right. And then we're going to talk about the different sources of impedance that I think are worth speaking about. So what is continuous delivery? To me, it's basically about building a factory. And that factory needs to be capable of delivering software in a very tuned and predictable and responsive way. And central to that factory is a network of production lines, and we like to call those delivery pipelines. And probably many of you are familiar with this book already. And for me, that introduced the concept of delivery pipelines, which is a fantastic pattern that we use. So our job is to build these pipelines and to industrialize our factory. So the backbone of continuous delivery is the delivery pipeline. And this pretty detailed diagram I've drawn up in the past. It's on my blog if you want to read it in more detail. Basically, every one of those speech bubbles is something that I think is really good about continuous delivery. So obviously, you can see I quite like it. And today we're just looking at the high level. So what we're doing is we're building an orchestrated workflow of steps that are capable of taking the code from check-in through all the quality assurance into production and hopefully some validation once we're in production. And those steps, there are basically two types. There's steps that move the code around, so it could be a build or a deployment or something like that. And there are steps that validate the quality of the code. So for me, my primary focus is building that orchestration and maybe some of the steps that process the code. But generally, at very least, the build scripts are best with the development teams, and absolutely all the quality assurance steps should be with the development teams or the testing teams. So we need to build this, and we can then look at it like a production line and apply the principles from manufacturing, things like Eli Goldratt's theory of constraints, to basically maximize flow and maximize the efficiency of this pipeline. So, why do we want continuous delivery? I think it's about happiness. I think everything in life should revolve around happiness, even in big enterprises. And generally, from my experience, it does make people happier. So, we'll start with the developers. So they move from a life where they develop something and then effectively they put it on a shelf. And they know that at some point in the future, that will add some value. But really, it's kind of stuck in the process, and it could be weeks, months, even years, or maybe it'll even never get released. If we're moving to this world where we're releasing the code rapidly and continuously, it's just much more satisfying for developers. They're much closer to what code is in production, so they're good with the kind of DevOps thing of being able to be part of end-to-end support. And it's just much more satisfying to know that you're actually making a material impact with the code that you write. So on to operators. So in the classic DevOps versus Ops discussion, we say that stability makes operators happy, and of course it does, but it's kind of a false sense of happiness if we're achieving that stability by resisting change. And what's going to happen sooner or later is some big program is going to come along and they're going to have to release, and that we're going to break the change window, the change freeze or whatever, going to force some change in, and that unhappiness that comes following the brief period of happiness wins. So we have to build continuous delivery to make sure that we're good at doing change and we can keep operators always happy. And so finally onto the business. So they move from thinking of ideas and knowing that there's some distant time in the future when they can get it released, to knowing that it's, or maybe knowing that Agile means it can get developed quite quickly, but still thinking it's going to be a while before they actually see it, to actually getting it pushed regularly into production. And even if their ideas aren't good, they can basically iterate and experiment in production and keep pushing the change in. And I guess overall, a happy business probably means more money for everyone, and that at least will make some people happy. So the essentials, the fundamentals. So it's not exactly a new idea, but rock-solid configuration management is essential for the entire stack. I mean, we're looking at rapidly changing everything in production through our delivery pipelines. Can't have uncertainty about what's deployed where and what version things are on. We have to have that predictability. We need to adopt that mindset that absolutely everything needs to be version controlled. And if any part of the stack changes, even something like the server template, we've got a new version of our whole solution. We need to know we've tested that in its entirety before releasing it. So I like to draw a diagram like this, which we call the component breakdown structure. This is a real diagram from a real project. We started it around about January, and it was live by the end of Easter. So you can kind of gauge the amount of sort of size of the project by the time. We also were very pleased to get it live so quickly. I've disguised some of the names a bit to protect the innocent, but this is a real system with real components, and we're going to kind of look at that over the next couple of slides. So the next kind of fundamental, which has got to be right before, at least as a mindset before you start, is treating your platform as an application. So infrastructure as code could mean some nice Puppet scripts or Chef scripts or shell scripts, whatever, but it doesn't necessarily mean that they're going to be well controlled. And we wouldn't say kind of business application as code. We'd say business application, and we'd engineer it, and we'd test it, and we'd release it, and we'd test it, and we'd have kind of constant, and we'd monitor it, and we'd have constant quality control over that. And I think the same approach is needed for the platform, for us really to have that predictability of rapid releasing. Martin Fowler gave us the word, like the concept of the phoenix. So it's the mythical bird that bursts into flames and then rises from the ashes. And we actually like to use that as a verb and say, like, when did you last phoenix that environment? When did you last phoenix that data center? And at the most extreme, we can actually rebuild data centers, the whole data center, in about an hour. When you start doing that, you're putting your cloud provider under quite a lot of pressure, and which is quite interesting. So it's very important that you can have absolute confidence in your ability to rebuild. And the last essential is the mechanism for dealing with the change. So I've taken the component breakdown and put it on the right here, so that I can kind of fit onto the diagram the axis of change. It's all very well knowing exactly what's on the right-hand side. We've got to have the mechanism for the delivering the change to that continuously. So this is where we need a delivery pipeline. It brings us back to that, and all the automated steps, compile and move the code and test the quality. My team do it a lot with Jenkins, but there's obviously lots of other tools that do the same thing. And every component in our system needs the same treatment, even the platform down the bottom here. Now, as I said, this is a relatively simple project, and it had a microservices-like architecture. So a lot of the components genuinely could go to production without integration testing with other components. So it's very simple in that respect, very helpful to us. But the platform is clearly absolutely pervasive change. When you make a new version of the platform, you've got to control that flow. So this kind of I put this slide up just to talk about flow control. And you can see that we've got all the pipelines for the infrastructure, for RabbitMQ, for MySQL, for Cloud Foundry. We've got pipelines validating all the quality of that code. We can abstract that into a infrastructure release, platform release, and then we can to control the flows so that we test that infrastructure before we make those changes in production. So getting these things right, or at least having them kind of clearly understood, is absolutely the sort of bedrock of doing this. Maybe made it sound a bit easy, and these versions of the diagram are maybe a bit more common, or I know they're very common from experience. So instead of having a nice kind of fully understood component breakdown, if we try to draw it, we realise we've got quite a lot of grey areas. We've got things that were built once, that we know that the master configuration is in production. Maybe we version controlled the documents of how to build something, but then there's still a sort of slightly artistic element of actually building those servers and building the environment. So that integrity of our platform is quite, and of our system is obviously very difficult and a source of challenges. And then when we do our pipeline, it's very common to have lots of good automated steps and some continuous integration, but scaling that to as we get kind of towards the dizzy heights of production. It can be very difficult. So I'm going to look at the sources of impedance and how to deal with those. So in the spirit of lean and agile, it's important that we fail quickly, and there's really no kind of quicker way of failing than people. Obviously nothing happens without them, and the first sort of problem I see with people is ignorance. I don't mean that in an insulting way. It's just people in many organisations that I've worked in. Not everyone has heard of continuous delivery, and I think it's very important to have heard of it, have appreciation of it, and know that's what we're trying to do. So it's obviously lots of developers and operations staff have heard of DevOps and continuous delivery and are pushing for this, but it's a bit like Agile. If the business don't understand it, and if architects don't understand it, and project managers don't understand it, it can make things very difficult. So the solution here is basically actually have awareness sessions, brown bag lunches, whatever way is good for getting the information out. Webinars or memos or whatever the best way of getting information out. Have those sessions really trying to get this out as something people understand and know that this is the kind of the better way, and try and give them that vision. So you can do that, but then ambivalence could be the next thing. So people have heard of it, but they still don't really think it's for them. Quite often there's confusion with continuous deployment, by which we mean we're literally continually deploying it. Every single check-in can flow through and go into production. And as I said, we're tuning the flow of our factory. And it's pretty rare, I would say, apart from the kind of very select few where you're literally pushing the changes all the way through into production. And continuous delivery is about the automation and that lean process, but it doesn't mean you have to push the code straight into production. So the business might say, we just don't want to introduce changes all the time, or for compliance reasons you might not need to do it. And that might put people off and say, well, look, this is for the special few, this isn't for everyone. So, to deal with that, obviously there's kind of training sessions are a good mechanism. And also, I find hunting down where people are already doing this kind of stuff, and there's always kind of good sort of pockets of people doing this stuff, and kind of highlight that to people and say that this isn't something that gets done only in kind of Netflix. You guys are already, we're already doing it. We've already made some starts. So, and this is how good it's working already. So, don't be ambivalent about it. This is real. This is for us. So, the next thing is obedience, actually. So that could really be a problem. And by this, what I mean is, rightfully or wrongly, people just assume that they're not really allowed to do continuous delivery. It's not for the company, and it's not what their bosses are telling them to do, or their bosses' bosses are saying, and it just means something that they shouldn't really be kind of getting distracted with. And it can be incompatible with sort of tactical management, project management steer, maybe of just get this done, just cut every corner you need, don't automate the tests, just try to get it done. It could actually be seen as it could actually be seen as disobedience for not doing that. And it also, just general leadership steer. So if everything is all kind of tactical and save costs, then again, continuous delivery could be seen as incompatible with that. And so the solution here, I found, is get the executives endorsing this stuff. Get them at those training sessions saying, or releasing a memo, whatever it is, saying, we genuinely want to do this. This is for us. We've got a vision. We want to be like Amazon or whatever. I've heard that many times. And endorsing this stuff. And also you can kind of do demos back to them and get them to genuinely show their appreciation of the progress so that people know that actually it's obedience to do continuous delivery and not disobedience. So even if we've got that knowledge, people understand it's for them, and they've been told to do it, still disobedience can be a problem. And that's it could be because of the impedance reasons that we're going to come on to around the sort of technical challenges. And it also could be that they don't really have the means to do it. It's not really clear how they can actually do it. So governance is a very important thing to get right. I regard these things as lovely things: pipeline orchestration, config management. They're not for everyone. But these are the things that get neglected because they kind of fall through the cracks, and it can be very unclear who's accountable for them, who needs to get them right. And I've found, actually restructuring or whatever it takes just to get people to take accountability for this stuff is a very good start, and give those people the means to get it done. So what are the means to get it done? So quite often when I've read many things about DevOps, people like to characterize this picture on the left-hand side of a dev silo and an ops silo, and they talk about bringing it together, and there's lots of kind of quite sort of strong statements saying, don't create another silo. You've got to achieve it by merging those, by fusing those teams together. And I don't disagree with any of that thinking, but I think the diagram is often a bit simplistic, and actually on the right is what it can look like in many enterprises. So lots of different teams, different platforms, different vendors, different software products, different suppliers, and there's just lots of silos already. And genuinely having someone, maybe a kind of DevOps kind of catalyst team to get some of this stuff started is very effective. I've seen it working. I've done it many times. Another approach, which perhaps is a bit more long-term, is to have a platform team and to give them the development of the platform and make them like another kind of product-oriented team. Actually finding out who does this stuff and getting the people to do it is difficult. Read the warnings about DevOps teams, but don't be afraid of them. So. Okay, on to infrastructure. So if people and culture have been considered, and we've kind of got some of that stuff, we still don't go very far without infrastructure. We want to version control everything. We want API access. We want to be able to destroy things and recreate things. Far too many times I've been in a situation where getting a server is a bit more like this. You start off by pretty much lobbying the infrastructure team, almost like MPs, to try and pass a bill to say, look, we need a server. You can't just turn up at the meeting. You've got to lobby them beforehand and say, you need this server. Then you get the server approved, and then you've got to wait. You've got the waiting time. So it could be 6 weeks, 12 weeks, months, who knows. You finally get the server. It's not quite built to the spec you wanted. It's actually quite a lot smaller than what you wanted. So you do a bit of a kind of iteration of getting the server into the state that you wanted it. And then you finally got the server, you haven't got any access. You finally get some access, you still don't actually have root access to the server, and it makes it pretty difficult to use tools like Puppet and Chef when you just don't have control. And that is a massive source of impedance to trying to do continuous delivery, and it just really doesn't work. So the solution for me is to start with the public cloud. It's extremely good for productivity. You can do everything you need, the APIs, the version control, it all just works. You can minimize costs, use small servers, switch things off when you're not using them, and basically just show everyone where the bar should be in terms of the infrastructure solution that you need to do continuous delivery. And once that's kind of been established, there's plenty of time to work out where to go from there. Maybe you will actually end up using more public cloud, or maybe your organization can look at how to improve and how to build a private cloud and how to get the same kind of levels of capability and service with infrastructure so that we can do this stuff. But without a good infrastructure solution, I think it's pretty much a non-starter. So even if you do have infrastructure code, it is code. Treat the platform as an application and engineer it correctly. Infrastructure code is very powerful, so obviously it can be very dangerous. Subject it to the same engineering as everything else. Build pipelines, and it doesn't have to be quite so scary. If it's release managed and it's very clear when you're going to move to a new version of the infrastructure or the platform application, then it can be controlled and it can be safe. So I think there was a question about this earlier, about software products. So commercial off-the-shelf products can be a massive source of impedance to doing continuous delivery. Our needs are pretty simple, right? We want to be able to version control, we want to be able to work offline, we want to be able to merge, we want to be able to build from the command line, do static code analysis, quality assurance, we want to deploy the code. And every one of these things can be done very easily with a language like Java or Ruby or something like that. There's whole worlds of tools like SonarQube and checkstyle lint, fxcop to validate the quality of the code. There's just options all over the place. And obviously, building from the command line is just a native concept. When we get into software products, it can just be a fight almost every step of the way. It's quite common that they kind of have this mentality that you've got maybe 2 test environments and you sort of develop in one using the mouse and then you push across to production and that's the end of it. And that just doesn't scale and it makes it can make it a constant fight to do continuous delivery. So it could be perhaps it's difficult to get the stuff actually into version control in the first place because it wants to version the stuff itself. When you do export it, it could be that it's binary or like proprietary XML that you can put into version control, which you really can't merge. Build could be slow. It could be slow, even if you can build from the command line. Quite often it's like a monolithic build, and I've even seen command line tools which are just a headless version of the IDE. So it's still a pretty flaky way of building the code, even though it's the command line. So it can be a battle, and I'd love to say there's a solution here. I think that just the way to overcome this impedance is pretty much determination and belief. It is possible. Continuous delivery does apply to COTS products like this. It is worth it just as much as everything else. And of course, you can involve the vendor, and COTS products vendors are obviously hearing this stuff more and more now. And there are ways of doing it. Asking them, how do other clients? You told us when you sold us the product that all these other clients are using it and they love it. How are they doing continuous delivery? How are they tearing down the environment and rebuilding it? And work with them, and it is possible. I mean, it's a pretty sad day when you end up kind of screen scraping and driving the mouse to do the automation, but it's still probably worth it in the end, just to be able to have that confidence of continuous delivery. So the last thing I'm going to talk about is complexity. So it's even my first diagram of the pipeline, it's just kind of one version control repository, nice and simple, one pipeline. But actually, we've got lots of software components normally, lots of different pipelines, and we need a way to deal with that. We need to track what versions were tested together, how we control this flow, and what we should release. And building all these pipelines independently doesn't really help with that. So the solution for me is to build integrated pipelines. I've actually spoken about this before at a Jenkins conference, so there's a video on YouTube. I'll go through this in a bit more detail. Basically, the pattern that we use involves 2 types of pipelines. So you've got your continuous integration pipelines, which is kind of what we expect, and they start with source code and a check-in, and they do all the good things. They fail fast. They notify small numbers of a smallish team that they've made. They've failed the build and they failed the pipeline, and they can then deal with that. When you deploy 2 or more of these into a common environment, you really need to start now thinking about the integration, and you want to handle those with an integration pipeline. So this is our second type of pipeline, and it usually starts with a deployment into an integrated environment, and then after that, the code components move in sequence together, and you know that you're releasing a tested version that was tested in the first environment together, where these 2 components first met, and they carry on working together. So and this pattern is great. It scales very nicely, so you can have integration pipelines of integration pipelines. And kind of what we're doing is we're taking that component breakdown, which I drew earlier, and turning it on its side, and then just building a mechanism for dealing with that. So complexity doesn't have to be a problem. So that's it. I hope this has been useful. As I say, I do think continuous delivery is absolutely applicable to big enterprises, even with some kind of gnarly sources of impedance. It's definitely a source of happiness for everyone involved. It's definitely worth the challenge. And yeah, if you want to have a chat about, or read anything else, please get in touch. Any questions? No? Spare time. Hi. Yeah. So I think is the question, infrastructure is, well, it may be virtualized, but it's kind of a physical thing, unlike a logical application. And is that the question? How do you deal with that when that becomes physical? Is that? Yeah.
You don't get the infrastructure requirement in a single page of document or single requirement.
Yeah.
You get a series of requirements, and we need to deliver it quickly.
Yeah.
Because agile environment, we need to deliver it quickly. In that situation, you cannot convert the infrastructure into a code and then deliver it. So it takes time. It doesn't work in real time. So that's why
Okay.
to manage that kind of problem.
Okay, so the question was, how do you treat your infrastructure as an application and manage these kind of disparate scripts that work for different roles, different server types, and treat them as one? Is that right?
The requirement comes so frequently, and it's not like single time requirement. So user wants a new application, new user to create a new permission to be assigned.
Okay.
Small bits
Yeah.
of information. So it takes time to convert the code, and the user wants have patience to wait till I convert the code and deliver it form of code. One quick response. So how to cope with that situation?
Okay, so how to cope with sort of the rapid rate of change that you need with infrastructure when you're managing it as code? So it's a good question. One way that we, so I've drawn the pipeline. I've talked about the flow of the platform changes into production. One technique we use is semantic versioning, where you have meaningful version numbers, and you can basically make small changes which don't impact, which are kind of internal changes, but don't impact the other systems and the kind of safe changes, and only increment that minor version number. So you can basically make changes to your platform and still know that you don't need to tear everything down and regression test it. So one mechanism is to have changes which are kind of non-breaking changes and support them that way. Now, how to make those changes? Would you make those changes by encoding them in your infrastructure code, or perhaps doing it manually through the command line or something like that? So if you're using something like Puppet or Chef, then again that gives you the ability to evolve a server, so you can still make the changes in your say manifest file and add those users and say these users must be present on the box, and then it will converge those servers and make the updates you need, in real time, like we saw in the demo just now. Okay. Any more questions?
Okay, thanks, Mark.
Thanks.